Okay, 707 is about integration involving logarithmic functions. So there are two basic formulas here. This is the basic one. The dx can combine with the one up the top, so it becomes dx on x, and that equals log absolute value of x plus c. That's not on the reference sheet. This one is. It's the same thing. If f of x is just x, then the derivative is 1. So anytime you get a fraction, what I would be looking for is the numerator the derivative of the denominator? That's the first thing to think about. So here's an example. In this one, the numerator is exactly the derivative of the denominator. So we can just go straight there and do log absolute value of 2x minus 3 plus c. So that one's very easy. Okay, in this second one, let's start by looking at what is the derivative of the denominator. So the derivative of 3x squared plus 2x is equal to 6x plus 2. Now if we compare that with our numerator, we can see the numerator is exactly double that. So if we wanted, we could factorize 2 out of there. When you factorize the 2 out, you could just put it right in front if you want, or you can put it behind the integral sign, which I'm going to do. So the integral from -5 to 2 times 6x plus 2 over 3x squared plus 2x with respect to x. Okay, let's tidy that up a bit. So now the numerator is exactly the derivative of the denominator, so we know it's a log. So 2 log absolute value of the denominator. It is a definite integral from -5 to 2. So I'm going to start by substituting in the 2. So 2 at the front, big brackets. So log of 3 times 2 squared, so 3 times 4, so 12. 2 times 2 is 4, minus log of substitute in -5, so positive 25 times 3 is 75, minus 10. So 2 log, I'm going to use the log law for minus, so I'm going to put them both in here as a division. So 16 over 65. You can put that in your calculator if you want to. It equals -2.8. Okay, it's negative because there's more area below the x-axis than above it. Okay, just this one quickly. Now the numerator is not the derivative of the denominator. The derivative is 3. But I can times that by 3 on 3. So then I've got a 3 there. I could have put that behind actually I might put that behind there instead. Okay, so I've times it by 1. I haven't changed its value. I'm going to switch the 3 and the 4 because 3 times 4 and 4 times 3 are the same thing. So 4 over 3 times the integral of 3 dx on 3x minus 7. So now we do have the derivative of the denominator. So 4 on 3 log denominator plus c, always the plus c. So you may have to do a little bit of fiddling with that. So just multiply it by whatever you want. So if you need a 3 there, multiply it by 3, balance it with a 3, so you're only multiplying by 1, and switch them. Whatever you need there, you can just do it that way. Okay, here's a practical problem. A particle moves with velocity v equals 5 on t plus 1 meters per second. Given it is initially 2 meters to the right of the origin, where is it after 1 second? Okay, so for this problem, we've been given velocity and we want displacement. Now remember, velocity is the derivative of displacement. So displacement we normally use in x. I might write, So x is the integral of velocity with respect to time. So it's meters and seconds as given in the units there. Okay, so let's just go ahead and integrate that. Now that's 5 times 1 on the top, so there is a 5 log t plus 1 plus c. We were given initial conditions. We were told that initially, so when t equals 0, x is 2 meters to the right. So I'm going to call the right the positive because that's just the natural thing to do. You don't have to, but I'm going to. So x equals positive 2. So 2 equals 5 log 0 plus 1, so log 1 plus c. Log 1 equals 0, so 2 equals c. c equals 2. Okay, now the question was, where is it after 1 second? So let's first of all start by just writing our displacement equation. So from this line here, so 5 log t plus 1 plus 2, because c equals 2. We want to know where it is after 1 second, so we're just substituting 1 into there. If I said after 1 minute, you'd have to substitute 60 into there, of course. So 1 plus 1 is 2, plus 2. I don't need that absolute value anymore, of course, because 2 is positive. If you put it in your calculator, it's 5.4657 meters. It's positive because we said positive was to the right. It is 5.4657 meters to the right of the origin.